exactly that they catalyze the reaction of aldehyde to corresponding acid, and that's important. This is important. This catalyst, this is important because one line I can say that we eat glucose, and the glycolysis says the glucose is ultimately changed to carbon dioxide and water. That's what you know. These primitive things, what they tried to do first, they took carbon dioxide and water and they create glucose. But that we know that the plant they do. But I am referring to not plant, I am referring to a dark situation where there is no plant. Plant has to wait a long time. Here also they would be handing their pattern to source of the plant so that slowly plant can evolve to take care of carbon dioxide and form this thing. So anyway, so we have that some of the extreme conditions, some of those type of these are called extremozyme or extreme species, and it's a very bad place. I see high pressure, methanzine genus, 250 atmospheric pressure required, 85, and then it survives. So this is, and so fortunately if you have carbon dioxide and with hydrogen, and then they can create methane a lot. This is the microbe, and it is also hostile, it stays there. So if an energy problem, one can use this type of microbes if people are interested. So here I wanted to see the black smoke are here, some of those clusters which are important in chemistry, how they react with carbon dioxide to acetic acid. They reverse glycolysis, that reaction they do. And these are some of the fundamental small metal clusters, they are involved there, and those are all known. This is the reaction that one can make, a couple reaction by which from hydrogen proton one can get hydrogen, which is essential. This is a detailed chemistry. I don't want to make like problematic, but it is only one thing I wanted to tell, that this is a energetically favorable, negative. This reaction we want because carbon dioxide is very difficult to reduce. So it is a positive. So what happened? Both the reactions are coupled, and finally we get the negative. So when both are coupled, we can get it. The coupling মানে হচ্ছে খুব সোজা। আমরা বালতিতে করে জল তুলি তো জলটা তুলছি একটা পুল, আমরা টানছি, বালতি উঠছে, দড়িটা কাছে দিয়ে কেটে দিলাম, ডিকাপল হয়ে গেল। মানে আমার শক্তি দিয়ে আমি জলটা তুলছি, জলটা তোলাটা হচ্ছে আপিল, সেটা পসিবল নয়, এনার্জি ডিমান্ডিং। কিন্তু তাকে যদি আমি ওঠাতে চাই, একটা দড়ি দিয়ে আমি কাপল করবো, টানবো, সেটা হচ্ছে কাপল রিয়াকশন। সো এই রিয়াকশনটা হচ্ছে দড়ি দিয়ে টানা, আর এইটা হচ্ছে জলটা তোলা। এই দুটো যদি একসঙ্গে লাগিয়ে দিই তো ওটা হয়ে যাবে। এবং বায়োলজিতে এরকম অনেক রিয়াকশন আছে, কাপড় হয়ে যায়, টেনে নিয়ে আসে একটা কারেন্টটাকে। নাহলে একা দেখতে গেলে একটা যে কোনো থার্মোডাইনামিক্সের লোক বলে এ তো হয় না, কিন্তু ওইভাবে তারা টেনে নিয়ে যায় এই জিনিসটা। So the thing, this is the glyceride phosphate oxidase is a primitive archaeal protein where you can see most of the things are pyridoxine, sulfide dehydrogenase, all these are sulfur, H2S, iron, all sorts of things there. The organic chemistry is very minimal there. So that's I wanted to say that the fossils they have seen that iron sulfide is there. It has a connotation that they have very close to that, and all these lives are there. Now this is important, that what I wanted to say, how the cells are formed. The cells are formed here. এই হাইড্রোথার্মাল ভেন্টস থেকে জোরে সালফাইড বেরোচ্ছে, আর এটা যেন সাবান গোলা জল আছে, একটা লুক দিয়ে একটা বাচ্চা ছেলে দিয়ে সব কিছু ফু করলে একটার পর একটা সাবানের গোলা বেরিয়ে যাচ্ছে, এক্স্যাক্টলি সেই রকম এখান থেকে সেটা বেরোচ্ছে আর এখানে জলের মধ্যে আয়রন আছে, এসএস বেরোচ্ছে, একটা ওই চাপের মধ্যে এরকম একটা তৈরি হবে, কিন্তু ভীষণ বিটল, ফট করে ভেঙে গেল, হোক আবার বেরোচ্ছে, সেকেন্ড, থার্ড, ফোর্থ, ফিফথ, সিক্স, এরকম করে করে ওই ঢিপির মতন একটার পর একটা হয়ে যাচ্ছে, and that takes 800 million years. But what happened? We refer to this is the first freshly prepared iron sulfide, first generation, the second, third. This is the way the cell started, membrane started forming. And when it is forming, with the fissure troughs, some of the organic molecules are forming, and slowly they are embedded inside, and so making this more less brittle. So that is the thing, that with the organic incorporation, this type of membrane get less brittle, and the signature is still there, because most of the membrane bound proteins are iron sulfur proteins, so they are still there, that one can have the signature that they are still there. So this is the way that one can think of the birth of a protomembrane in this way, that one can visualize. So this is the sea surface, where it is a low pH, and sodium sulfide is a high pH, and so across this there is a proton gradient. So the pH means that the pH is, proton is different. So in that way one can think of the cell, the modern cell. This is the membrane I am referring to. This is the membrane I am referring to. What is inside, that is not important for me, because inside these molecules have been created separately, but they have to be housed together, and how this house can be formed, and that is the membrane part, that one can make it in this way, and the membrane slowly proceed. One caveat that is important, that people try to understand: the reproduction is based on progressive improvement of metabolic cycles that become more and more elaborate as the time progresses. And this is what we need to understand first in the deepest reflection. This reproduction. People talk about reproduction, cell is divided as reproduction. But it's not like a copy, like computer, that I have a city, I can get another city. It's not like that. That here in the program, it replicates identical copy, but cell reproduces, makes a similar copy. ছেলের সঙ্গে বাবার সম্বন্ধ থাকে, কিন্তু ছেলে একটু তফাৎ হয়, স্লোলি এভলিউশন হতে থাকে। হ্যাঁ, বাবা একটু মন্দবুদ্ধি হয়, ছেলে হয়তো একটু বেশি বুদ্ধি হতে পারে, আস্তে আস্তে ইভলভ করে জিনিসটা, একবারে কপি হয় না। কিন্তু কম্পিউটারের একটা, আমি সিডি যদি একটা প্রোগ্রামকে কপি করে দিই, এক্স্যাক্টলি সেটা কপি, সেটা হচ্ছে কপি, সেটা রেপ্লিকেশন। কিন্তু এখানে হচ্ছে রিপ্রোডিউস করার মধ্যে আছে, মেক এ সিমিলার কপি। তো এই দুটোর মধ্যে একটুখানি তফাৎ আছে, সেটা মাথায় রাখা উচিত। It's simply that I wanted to show that even today there are some microbes where you can find that in the deeply buried here, the sulfur cycle is there, and electrons get, and slowly it goes, and here it is oxygen, and then it puts the oxygen there, electron there to keep, meaning thereby they still keep the older fashion of sulfur, the sulfur cycle. Why sulfur cycle is more important than oxygen cycle? H2S to sulfur, and oxygen and water. ওয়াটার আর অক্সিজেনের হচ্ছে ভীষণ হার্ড, থার্মোডাইনামিক্যালি হার্ড, মানে জল থেকে অক্সিজেন করাটা একটু শক্ত, কিন্তু H2S থেকে সালফার করাটা খুব সোজা। সেই জন্যে নেচার প্রথমে সালফার দিয়ে আরম্ভ করলো, একটুখানি ঠিকঠাক হয়ে গেল, সালফার শেষ হয়ে গেল, H2S শেষ হয়ে গেল, আস্তে আস্তে জল আর অক্সিজেন নিয়ে ধরলো, এবং জল নিয়ে অক্সিজেন ধরতে দিয়ে এইখানে যেমন সালফারটা বেরিয়ে আসছে, অনেক বেশি অক্সিজেন বেরোতে আরম্ভ করলো, আর সেটা হচ্ছে 570 মিলিয়ন ইয়ার্স এগো, এবং সেই অক্সিজেনটাই এতে আরম্ভ করে সার্জ অফ অ্যালবাম গ্রোথ, তাতে গাছপালাগুলো শুরু হয়ে গেল। তো এই these are some of the primitive reaction, carbon dioxide, how that can get the methylation slowly, এরকম করে হাইড্রোজেন পাওয়া গেছে, এরকম করে slowly they have changed, formaldehyde হয়েছে আস্তে আস্তে, and whenever there is a problem, that's one important thing. So whenever there is a problem, they survive. How? A primitive slice of life due to scarcity of food adopts exotic metabolism and very slow rate of reproduction. So they can go for hibernation for hundreds of years, thousands of years, without food, anything like that. And once they get the food, they start it. আমার মনে সময়টা শেষ হয়ে গেল, তাই আমাকে অনেক কিছু স্কিপ করে দিতে হবে। So the similarities that what I wanted to convey is something like that this is a phylogenetic tree, and here one can make it that it is archaeal, bacterial domain, eukaryotic domain, and there are certain functional molecules as I was stating that it has got a common, very common thing, some very common things. We started from here, archaea, that is with the tungsten, and then here it is tungsten and moly, and then sulfide oxide that is there with human is purely molecular. So the mineralogy like the cosmic chemistry, volcanic chemistry, here is the part, that is the part that I wanted to touch, that's a pre-RNA and post-RNA, everyone we know. So that is the vector representation, there is a geochemistry first, this is a prebiotic chemistry, this is the RNA, and then with the protein creating RNA and then DNA, and this is the vector. In that way one can get the temperature, all these molecules, and one can get, and slowly one can evolve the universal ancestor. We do not know which one comes first, but this is the way things happen. I can skip those things, that the carbon assimilation in the dark, that's important. Leave that thing. This much I can say that the carbon dioxide to formaldehyde that's formed, formic acid, that thing in the hydrothermal vents, what the knowledge Earth gathered, that transferred to with the sulfur, this type of photosystem with the solar energy, no longer thermal energy, and here you see that there is no longer the common what you know about water, but this is something with the hydrogen sulfide. These are the primitive type of green bacteria or this type of heliobacteria. They do this type of thing, and then slowly evolve with our modern photosystem. As the hydrogen gas escaped, it is depleted, water is used as an alternative, and initial oxygen started oxidizing, and oxic environment started emerging. That is 570 million years ago. So this is time scale where one can say first free living cell, and where these are the things there. And oxygen level is something like here. So one can make it that slowly within so many years passage, one can see the development of all these species. I can skip this. Yeah. So finally we have the aerobic photosynthesis. One thing I wanted to say that this Earth is not unique where life can be there. Now there are enough evidence. There is a habitable exoplanet, alien life, Kepler 22b, is 244 times Earth size, circles a star that's quite close to size and temperature to Earth's sun. It has an estimated surface temperature of 22 degrees Celsius. Its star system is about 600 light years away from Earth's sun in the constellation of Cygnus. So it is in the NASA that they have released December 2012, so very recent. So one can see that its environment is exactly similar to Earth, and then one can anticipate if that be the case, and if we believe that all these stars and planets are born created by Big Bang and they are followed by some supernova explosion, then there is no denial of the fact that we can have all the elements so that what we have here, they are also. If that be the situation, the weather is very conducive, the environment is very conducive, and there is every possibility that one can have alien life there. Now life means it is not human, it is only the microbe that started. And then comes Darwin with the evolution. Slowly they try to evolve, and sometimes dinosaurs and other things they came, and then the rise and fall of dinosaurs, and slowly other things appeared. So I tried something to say about life, but where we failed to say something about this, that with this type of chemistry we still cannot account morality. That how morality can be developed, that probably we lack that type of chemistry till we don't understand what should be the chemistry about the morality. So, on the constitution of human nature to build the constitution of human societies, and that is something that still we have to deal with.
This life from the Darwin theory, it has evoluted. Does this evolution ceases or it will continue? Then superhuman or something more intelligent life will be created, or it has already ceased? Optimum condition has already reached.
That's true. The question comes that we do know that with the evolution, slowly, as for computer, you know that the primitive computer is such a huge, and it has got memory this much. But now we have a microchip so small, and it has got a memory a lot. So is the case with human, that with evolution, you can slowly see that bodily probably that we are getting shorter and shorter because it is compact. But then this one is expanding like anything.
So evolution is existing.
Evolution is a continuous process.
So superhuman will be there.
I don't mean superhuman. What do you mean by superhuman?
Now
the question,
when it will come from dinosaur,
it's a slow process. I can give you one example. একটা গরুর বাচ্চাকে যদি আপনি কোলে পারেন না, বাছুরকে, হ্যাঁ, করতে থাকে রোজ, যখন ও বড় হয়ে যাবে একবারে, তখন কি বুঝতে পারবেন?
That is a practice, habit.
But
habit
exactly. So we are evolving, and you are unable to understand we are evolving. আমার দাদুর যে ব্রেনের স্টেজটা ছিল, এখন আমরা অনেক ইভলভ হচ্ছে। সুপারম্যান বলতে গেলে there is no demarcation. It is a continuous process. Today's Superman is definitely will be superseded by in future a more Superman. That's I mean.
That's right.
Yeah.
So, if you please clarify 2 points. One, at least the first one, that many people define life in different ways. One of the main things that I read or I know of actually, that there must be cell division, mitosis somewhere, in order to from one cell to multiple cells, in order to build up the tissues and other things. You didn't mention much about that, except reproduction. One slide you talked about. At what stage that started? When did the cell start in the mitosis?
Meiosis.
No, this as I didn't address that thing, but because that is simpler to approach. A cell when it is started to grow larger and larger, there is a capability, because the membrane is there and there is some fluid inside. So that will try to divide. It can burst open, no problem. Now previously when it started to burst open, it found that the entire whatever it achieved, that was lost. So how it can open slowly, so that is some experiment is tried to do, so to keep it. So that's a process, how it can be slowly, they started the what you call meiosis or mitosis or the cell division. That is possible. But the same thing, that what I state, that here the bubble after bubble, the one bubble burst and immediately that may be followed by a couple of bubbles. So one can view an environment where out of one you can have immediately two. that can be evolved.
But when did it start actually? That particular aspect which is critical for the animals to, animal body or human body, then when did it start?
To perceive this is a little bit difficulty with all we face, because it is not with animal. We are talking about now a microbe which are the first decade. So they are having very primitive part, and I mean to our mind we are all the time talking about trees or animals. We can relate. We are not. It is Cenozoic era. We are there at the extreme end that we came. So then Earth evolved a lot. So first we try to understand the most primitive type of cell, that how they, and once the knowledge, information, slowly that is the evolution, the best way to survive. So Earth has got enough time to experiment, and they tried n number of ways to do those experiments. Those experiments which do not carry a better thing, it's redundant, but then it has got still enough time to do, and ultimately you get that thing. So that is replication of that, the cell division is a process that one can make it even today. A water drop, if a water drop is there, is a thermodynamic thing that if it's a big one, you can easily see that when it can split to two. So that is a driven force is already available there. So when it approaches a particular limit, if the membrane is good, so they can slowly that can be divided. You have seen that water drop, so that can divide. So these are the ways by means that one can conceive the idea how the cell can be divided.
Thank you. Good afternoon, sir. I have a question.
Yes.
The fact is that what is it so that makes the complex macromolecules to be associated with life?
What is so?
What is it favorable for taking the?
Which macromolecule you are referring to? Can you give a specific example? There are n number of macromolecules. They are all diversified.
I am talking about the biomolecules, sir.
Yes. Say for example, for our respiration, we have a macromolecules like hemoglobin. Okay. For protein synthesis, we have macromolecules like RNA and DNA. They have an entirely different story to do. Now the question comes, one try to understand that the life was created from very open system. It is not a very sophisticated laboratory where you can find your conducive environment, where you have a particular type of environment to create, so that you can have very sophisticated environment, say under glove box, under argon, or with a complete good pressure, air condition, something like that. It does not have anything. So it started from very ab initio, a very crude way. Now how to protect its reaction house from the hostile environment, where it does not allow that the environment should be there, so that some of the very important reaction it wanted to carry out. Normally we know only that all living things are in water, but if we understand that is the dielectric, the maximum 78 for water, and a lot of hydrophobic pockets are created by this macromolecule, where the reaction sets in, which would be equivalent to that. The polarity would be so less, it would be something, the dielectric constant would be 2. It would be equivalent to that the reaction is taking place in carbon tetrachloride or benzene. But that is the same inside my body or your body. So the macromolecule has got enough task to do to isolate it in a proper way, so that it can have that type of environment specifically meet that what type of reaction it wanted to do.
Sir, another question.
Yes.
And I just have another question. In the very first few slides, you showed that during the daytime, when the DNA or the RNA was trying, when the RNA was trying to come together to a compact form, then it got broken up or chopped into pieces. That was because of the UV rays, the photons of the UV rays.
Right.
My question is that if the temperature is concerned about that factor, then why didn't the infrared rays had that impact on those molecules?
Infrared?
Infrared, because it is concerned with temperature. For the very high temperature, infrared is a source of origin for that thing. That is it only the frequency of the ultraviolet rays, or it is also concerned with the temperature also? That is my question.
If you look to the DNA RNA, it has got a chromophore at say 260. So people know that at a 260 nanometer radiation, DNA RNA can be cleaved. And the hard young sun, no oxygen, so no ozone layer, so all ultraviolet radiation is falling. So there is a very common way to think that whatever the long strand DNA RNA created, first when the day temperature rises, it is denatured. So the double helix coat single strand. And then with the UV radiation, these are sliced. And once more in the night when it gets cold, no UV light, it's tried to reassemble. The process is on only because of the fact that it's trying to make it permutation combination, all sorts of things. That how this order, the base pairs can be created, and then trying to experiment which can create some form that what the earth was trying to do. Ultraviolet and you talk about infrared.
That is a source of very hot field. Whenever a body is very hot,
But the thermal energy. So we are talking about the infrared, that the water was hot, but in the daytime, some days, water is a little bit elevated. You see on the top. If we talk about the bottom, there is a lot of heat. That we know. But here is predominantly ultraviolet radiation. That even you try to give the infrared radiation, I don't think you can cleave DNA.
and that is because of frequency.
Yeah, that's true. You cannot do
That is what I am saying.
Can we have one last question?
One question.
Yes.
Yeah, so far we have heard about physics and chemistry,
Yeah.
but life, a living being lying here and a dead being lying here, what is the difference between it? Chemically and physically, these are same. But what is the difference?
The difference is that all the reactions are in equilibrium. The life is something where you all the time try to avoid equilibrium. That is by thermodynamics. That we try to deviate from equilibrium, we don't try to do anything that all our reactions would be in equilibrium. When everything sets in an equilibrium, that's we define death.
Yeah, but after death, it is something like, no movement, no growing, nothing there.
I said that we have to talk about the first law and second law of thermodynamics. The light cannot violate that. If light violate that, if those things, then there's no light, it's dead. We deviate from the first law and we try to evade first law and second law only by that we are with the surroundings. Now the time that you are not with the surroundings, say for example you cease to take your oxygen, one can think of. So you are not with the surrounding, you are refusing to take the oxygen. So you are whatever inside is there, you are trying to go for an equilibrium state of mind.
Yeah, but the basic question, how it started. It's a automobile engine, fuel is there, machine is there, but it's not, operating. But when a spark is there, it started operating. But what is that spark started? That's the
Your question is that well taken, but I can tell you, you said that automobile engine, I can tell you something. I take a little bit of glucose, and the glucose is burnt, I know, and carbon dioxide and water. Take little bit of glucose in a glass and put oxygen, whether that will be burnt?
No.
No. So the automobile example cannot be put it here. The automobile example cannot be put it there. That is not. Both the things are roughly same thing doing. So I can cite a number of examples here. It is something that it requires energy by some means. You refuse to take those energy, and you are cut off with the surrounding, you are avoiding, you are just the thermodynamics, that I first and second law, that sets in, and that lead to you in equilibrium. And once the equilibrium is set for all your reactions, then you can proclaim that one can proclaim that you are dead. That's the thing.
Thank you, Professor Sarkar. Let us all give an ovation to Professor Sarkar.